All right, good morning, everybody. This is the Gardener community meeting. Today we have two topics on the agenda. First, Adel will talk about reversing the Gardener tunnel. And then we have Andre from Flint talking about machine controller manager and its role as a building block of Flint's hybrid cloud. The meeting is recorded and will be published on YouTube, as you know. Adel, you can take over.
All right, so let me share my screen. Okay. Do you see my screen?
Not yet.
Not yet. Okay.
Now I can see it.
Okay, perfect. So hello, everyone. I'm Adel Zaalouk from the Gardener team. Today we're going to be talking about how to reverse the Gardener tunnel. So what is the current architecture for our tunnel at the moment, or how do we use tunnel in general in our seed to chute architecture? So basically, if you're new to Gardener, we have a seed which contains the control plane of a cluster, and we have a chute that contains the data plane and the system components for that cluster. For the control plane, which is basically the API server mainly to connect to the data plane to do stuff like pod execs, proxy, port forward, logging. If you want to also node proxy or service proxy, we have a component in Gardener, a special component, and also a special repo for OpenVPN that we build scripts for. And what happens is we have the client on the seed side, and the server is on the chute side, and that means that we need to be able to reach to the chute over the internet. And we do that by adding a load balancer on the chute side, and so for the API server to access it. In addition to the API server, there are some components in the control plane that would wish or would like to talk to the chute. For example, for Prometheus, for scraping metrics from cAdvisor or from nodes or from other components that we run on the chutes, mainly system components. For the rest of the components in the chute, or for the custom user created components, user usually create their own Prometheus, so this is not a problem. So now we have two places where we need OpenVPN connections to be established from the seed to the chute. So what is the problem with this approach? The problem is that we need a load balancer per chute, which means that this is extra costs. In addition to the extra costs per chute, we'd also have a problem trying to achieve private access for some use cases. Some stakeholders or users would like to not have traffic from the internet reaching into the chute. They want to have full control over what comes in. And we're not currently able to do so because we have a load balancer that basically enables traffic to get into the cluster. Also, providing a public endpoint can be thought also as a can be thought of as a security risk as well. So we would like to eliminate that as much as possible. And in addition to these above points, we have now additional sidecars, as you saw. For Prometheus, we need a special VPN. We also need IP table rules to redirect traffic from the API server or from the seed to the chute. And for that, we also need to have disjoint sitters between the seed and the chute. And we have shell scripts for configuring that. We have scripts for building that. We have a special Docker file. We have to maintain that component ourselves. So can we solve any of these problems, or even all of them? Let's try. So what we want to do is basically we want to reverse the traffic flow. Instead of having the API server and Prometheus try to talk to the chute, we would like the chute to initiate that connection. This way, we don't have the need to create a load balancer per chute. And we control basically what comes into our chute or what doesn't come in, because probably there would be no need to expose unless we really allow or are willing in our design as users to expose traffic like with English or something like that. But otherwise, this is controlled environment. So this is what we want, and in that case, we will probably also use. So we already have a load balancer for the API server of our shoots, for kubectl, for example, or for ingress or monitoring. So we can see if we can reuse that load balancer. And here you see the dotted lines. So this is basically the flow. The flow is the Kube API server should try to talk to the proxy server, which then would try to talk to the proxy agent, and then we establish a tunnel. And Prometheus can talk directly to the API server to scrape the metrics, as I will explain soon, or it can have its own proxy server that again connects to the proxy agent. So let's talk about like the challenges and workarounds to achieve that. As I said, we have a Prometheus connection, or we have a Prometheus that scrapes our shoot clusters. So for the Prometheus connection to work, which used to work via VPN, we either need to deploy a dedicated proxy server that knows how to talk to the shoot, or we can utilize the proxy sub-resource to get to the shoot. And basically utilizing a proxy resource means that we go through the API server, so we don't need this additional extra sidecar for Prometheus. So this is something that we already can get rid of. And for accessing the proxy server on the seed, so we have 3 options. The first one is basically to use a dedicated load balancer for every proxy server, but this doesn't make sense because what we have done so far is try to get rid of the load balancer on the shoot. So it doesn't make sense to create a dedicated load balancer on the seed. It's just moving of costs from the stakeholder to the provider. Doesn't make sense. We can share the load balancer for all the shoot proxy servers, meaning that we have the load balancer for the API server and we have the load balancer for the proxy servers. Again, that is an optimization, but we don't want this additional components. The last thing that we can do, and this has a requirement, is to share the API server load balancer and its DNS name with the proxy server. And the requirement here is that the API server and the proxy server need to reside or talk to each other in the, basically reside as a sidecar. So the proxy server need to reside as a sidecar to be able to expose, for example, via the same service. Or if we want to expose via a different service, this can be also done, but this is the non-trivial case. So how do we do that? What components do we use? So there is a component that is already established in the community and in a SIG, Kubernetes SIGs. It's called the API Server Network Proxy. It can be used actually without Kubernetes at all. So its main components are basically a proxy agent and a proxy server. So the proxy agent is what will reside probably in our shoots. It tries to talk to the proxy server via gRPC and establish a connection. And then when our clients in the seed, or when a client wants to talk to the proxy agent, it uses HTTP Connect. What with HTTP Connect is basically you say, hey, I want to connect to that target IP via this server. And whenever you do that, the proxy server will create a mapping of IPs and connections of what proxy agent it has, and it will start to round robin or start to forward traffic from from the proxy server to the proxy agent. So here you can see there can be more than one proxy agent connecting to the proxy server. Each time there is a connection established, I keep a map, or I keep track of the connection IDs. And whenever I try to HTTP connect, I also keep track of the IP of the client or the identity of the client, and then I try to forward the traffic whenever the tunnel is established. So these are the 2 things that you can use. We can also use gRPC to connect to the proxy server, but this is something that we will not do. And again, in a Kubernetes context, why is it needed, or how does it look like? So the whole motivation behind the API server proxy was basically due to a vulnerability discovered by the Kinfold guys that allows users to proxy to a pod, for example. And if a user, or if a malicious user sets the pod IP to an external IP that is not controlled by the operator, then basically he can, or she can proxy to the API server, to that pod, and access that external service, although it shouldn't happen. So This was one of the motivations of creating this component. Another motivation was to have separation, because in the API server code, there is SSH specific code. So we use the cloud provider code to SSH and create SSH keys for all the instances in the cloud. This has been deprecated and should not be used except for GCE, but this is something that we would like to completely get rid of. And therefore, this component was created as a motivation. As a side effect of that component, it has this feature of allowing us to talk to or to invert the tunnel direction. And as you can see here, there are 3 types of connections in the figure. So there is cluster connection, where the API server would like to talk to the to the chute or to a cluster in this case. It doesn't. We have no chute or seed yet. It's here we have a control plane and data plane. They can reside on the same network, or they can reside on different networks. In that case, here it seems they reside on different networks, and therefore when the API server tries to talk to the cluster, it talks via the cluster connectivity proxy, or the proxy server. This is a special. This is a special connection, and there is another type of connection which basically is master. And master is, for example, when the API server tries to talk to webhooks via external name or not via service. Webhooks could be like image policy webhooks, admission webhooks, authentication, or other logging webhooks. And there's also the traffic flow where the API server tries to talk to etcd. So these 3 can all be separated and have different network context or different network dialers. For security, for isolation, or they can be shared. This is a choice, and this is what the arrows mean in that figure. So now that we have an idea a little bit about the proxy server in a Kubernetes context, how do we use that? So starting from 1.18, there is a new flag for the API server called egress selector config file. And this is where we actually specify these types of connection or context that I've shown in the previous figure. It could look something like that. So basically we say if the API server would like to talk to cluster networks, it should use HTTP connect as the proxy protocol. And as a transfer protocol, it should use UDS. It can also use TLS, for example. But in that case, UDS is a much better option because it doesn't go through the user networking through the networking stack, and it's basically talking over the UDS stands for Unix domain sockets. So everything is residing on the same network over localhost, and traffic is much or performance is much faster if used. You can also use gRPC here, and if gRPC is used, it cannot be used with TLS. So it has to be used with UDS. This is a requirement for this usage. And in that case here, we specify, we say, if we want to talk to master control plane components, we should talk via a direct connectivity. And a direct connectivity is nothing but a dialer. So basically these contexts is defined. There is a map between key names, which is cluster, master, or etcd, and the dialer type. In the case of the first case, we didn't use the direct. We assume that we don't have a flat network, so we don't have connectivity, direct connectivity or direct routing to the chute network, and therefore we use the proxy server. And when we use the proxy server, we say what kind of protocol I would like to use to talk to that proxy server. On the other hand, if I say direct, it means that I assume that I have connectivity, a flat network, or to the control plane components, and I can just use the same method I used earlier without the API server proxy. So no proxy server is needed in that case. And for etcd is the same. I'm using a direct connectivity. Why there is master and etcd? Because etcd is not really a fixed component. It can be replaced, and also it's better to provide a dedicated connection for etcd for scalability reasons. So this is a flag that once provided, the API server will start to look at these places to forward traffic. What is the the prereqs to enable this in Gardener. So in Gardener, now there is a PR already, and you can have a look. But the prerequisites, as I said, is 1.18, because this flag does not exist before 1.18. So this should be a motivation for people to to upgrade their clusters to more than 1.18. And we have a feature gate. You can use that feature gate to enable that feature. And the feature gate is called the connectivity tunnel. And once set to true, basically either the control plane will be migrated to use the proxy server and the client, or if you're creating a new shoot, then it will be created from scratch. So let me show you what these components look like in real life. Okay, do you see my screen again?
Yes, we can see it.
Okay, perfect. All right, so this is a 1.18 shoot cluster. And here, this is the control plane for that shoot cluster. So, oh, and by the way, down there, I have the Gardenlet. I have the Gardener controller manager, and I have the API server running. So as you can see, this is the API server. It has only one sidecar, and we have Prometheus. This is how it looks like in a new with connectivity tunnel. And this is a cluster that this is basically here on the right side. Is a cluster that is running via VPN. And as you can see, the Prometheus here is using an additional sidecar, which is the VPN. But let's look at the config map that that tells the proxy API server what, the API server what to do to forward traffic. So this is the config map I explained. It's created, this is the configuration I explained. It's created as a config map. And here, as I explained earlier, if we would like to talk to the cluster network, we would use HTTP connect as a protocol, as an HTTP proxy protocol, and a UDS socket, and I have to specify where this UDS socket is located so that it can be shared later on with whatever, with the proxy server sidecar. And here again, I say, if you want to talk to the master components, use the direct connectivity, because I have flat network. I can reach the control plane in this because they're on the same cluster, on the same seed, and same with etcd. How does it look like on the shoot? Oh, first, I forgot to show you something. So this is the deployment of the API server on the seed again. And basically, as you can see here, it's deployed as a sidecar to the API server. And we're basically saying that we're using UDS. This is why we're specifying the server port to 0. And we use HTTP connect, and we specify the UDS socket. And the UDS socket is basically shared with the API server, because the API server is referring to that configuration here, which is the eager selector configuration. So now the API server knows that it needs to talk to the proxy server to talk to the cluster network or the shoot network. And on the shoot side, we have a daemon set. And this daemon set is basically for the proxy agent. And the proxy agent is the component that starts the connections to the, or establishes the connection to the seed. So this is the other way around now. The agent is the one that started the connection. How do we know that this works? And as you can see, we have no VPN at all in this cluster. How do we know that this works? We can try to log something. As you can see, log works, which means that we're going through the tunnel. And let's try to, for example, exec into something. Yeah. And exec also works. And yeah, let's also have a look. So now that we know it works, let's see the other part of the equation, which is Prometheus. Prometheus needs to be able to scrape metrics as it did before without the VPN. So if I look at the deployment. So we see we have three containers in that pod. We have the black box exporter, the Prometheus, and the Prometheus config loaders. There is no VPN at all. So let's try to see if that will work. So this is Prometheus. Let's look at the targets. And as you can see, these are all our targets. And they are all using the proxy sub-resource to connect to the chute, but they are scraping successfully. Yeah, and this is working fine. So let's now to add the reference to what to compare to. Let's have a look here. This is the old model with the VPN. So in the old model with VPN, what we had was, as you see, there's Prometheus and there is VPN seed, which is the additional component that needs to be set. And if I, for example, look at the Prometheus here, I will see that, yeah, I'm not using the proxy sub-resource. I'm using endpoints, actually chute IPs, because here I'm assuming that I'm using the VPN tunnel to reach the IPs, and I'm assuming that there is a component that already tries to forward traffic to the chute, which is the VPN tunnel. Not using the proxy sub-resource at all, but yeah, this is a completely different way to scrape metrics from a chute cluster. And on the chute side for that old model, we had a VPN component. A VPN component would be basically the server. So we have a service for that. And this service is of type load balancer, which basically we have to have for connectivity to be established. Yeah, I think that is all for this demo. Yeah. All right. Any questions?
Yeah. Hi, Adel. No. Can you hear me?
Yes.
Ah, okay. So you showed us for the new approach that
there's some echo.
Hopefully not mine.
So
okay. So on the left side, you showed us there's only one Kube API server pod.
Yes.
What is if we have more replicas for that?
It works.
Does it also work?
Yeah. Nice question.
Okay.
There is a flag that you need to set to more than one, which is the server count, and to the kube proxy. And if the server count is greater than one, then basically a map of all the kube API servers for that seed cluster is created, and the traffic is forwarded to the correct API server.
Okay. So the proxy agents then connect to every single
exactly
API server replica. Yep. Okay. Yeah. Thank you.
Nice question.
And Adel, does this only work for clusters with version 1.18 and greater, or can this be also done for older clusters?
Yes, so we're trying to use the Kubernetes already provided feature flag, or the flag provided to the API server. So it's currently working only with 1.18, but this doesn't mean that if we want to put some effort, we can build our own client and attach it as a sidecar. Or you'd have to find or build in the client code somewhere. Currently, it's baked in the kube API server. We can get it out ourselves, or not get it out. We can disable it and then use our own proxy client. But then we have to again install IP table rules to forward the traffic to the proxy client.
Ah, okay, got it.
Which is, yeah.
So much more effort to implement it for all the classes, right?
Yes, yeah.
Okay, okay.
One question from me, Stefan here.
Yeah.
Hi, Adel. Nice talk. One question: if you start with a 1.17 cluster, for example, with the classic VPN approach, and then let Gardener upgrade to 1.18 and set the feature flag accordingly, will that upgrade process work as well?
Yes, it will upgrade and remove the VPN components from your shoot and creates the necessary components for the tunnel to work.
Awesome.
Yeah.
Hi, Adel. Thanks for the great presentation. One question, what kind of client credentials is the proxy agent using to connect to the proxy server?
Yeah,
Is it the same as for the API server? Or?
No, so for the proxy agent, it's using normal client TLS certificates. So it's using yeah, TLS certificates to connect to the server, and then yeah.
Isn't it using is it using?
You mean the server or sorry. Yeah, that was previously. Now it's using service account token. There are two options basically that I didn't mention. The first option is service account token, which is we currently using, and the second option is TLS certificates. Previously, it was using TLS certificates, but now it's using service account tokens. So, yeah, thanks for reminding me.
Hi, Adel. So one question, what do you expect when it comes to performance? Do you expect it to be faster, slower, the same?
Yeah, so that's a good question. I tried locally and I have not noticed any difference, but I think we still need to experiment with it a little bit. And if there's any optimization knobs that we have to set to see if there's any performance degradation, but from components perspective or from what I've seen testing locally, I've not seen any difference basically. Yeah, but probably because I don't have a very large shoot. But for a large shoot, the connectivity agent is created as a daemon set that it's available in every node. So that should minimize the traffic hopping as much as possible. But still, I'm not 100% sure if what are the performance implications. So that's why we have it for now as a feature gate to experiment with it. And in the future, if we found that it's matching what we expected in terms of performance, then we can just remove the feature gate.
Great.
One more question, maybe. This would work together with the SNI that Martin Fladev presented, right?
So the reason I didn't mention the SNI because it's actually independent of the SNI. So the SNI, what we do here, I can show you. So let me. Get service. Did I get the service? Oh. Here we use a load balancer, and in that load balancer, we share the load balancer of the API server with the proxy agent with the proxy server. So when the proxy agent tries to connect, it connects via the API server load balancer, except it's on a different port, right? And in that case, we have different load balancer or one load balancer per shoot. When the SNI proxy approach comes in, what will happen is we will be using one load balancer for the API server of all shoots, and basically we can still use the same load balancer, yet add another different port to it to forward the traffic. So this is completely independent of that feature. So once that feature comes in, we'd just have to make sure that we are exposing the right ports, and with Istio creating the right virtual services and ingress gateways. But it will be exposed via the load balancer again, same way. At least that's how I envision it. So it's an independent feature which when with the SNI load balancer comes in, should be also sharing the same load balancer from the API server. So no extra costs again here.
All right, cool. Thank you.
Hi, Adel. Maybe you already said that, but what is actually the underlying protocol between the proxy agent and the other proxy endpoint? Is it HTTP or
gRPC?
Ah, I see. And that proxy agent is somehow then making sure, I don't know, to reopen the connection if it breaks, or check the health, or
yeah, it keeps trying to reach to the API server. If the connection breaks, then it tries to reach it again. So whenever a connection, and then on the proxy server side, when traffic is directed to the chute, because we have a daemon set, so every proxy agent in that daemon set would connect to the proxy server, which forms a pool, and the API server would just, when it tries to initiating a connection, will just fetch one live connection from that pool, and then forward it to the chute cluster.
And one final question, you showed us the egress selector configuration in the Kube API server, where you had that 3 entries with etcd, master, and the other ones. Who sends these keys with it, or how does the API server know which one to pick of these 3?
It's baked in this API server code. So let me share the config map again. These are called network context. Every context of these corresponds to a different client. So when the API server tries to reach the cluster, it creates a node tunneler or a node dialer, and it has a UDS socket that it talks to talk to the cluster. And when it talks to master components or etcd, for example, the etcd client can use the proxy or can use the normal HTTP dialer, which is called the direct dialer. So it's baked in the code, and whenever you're creating the client, you decide based on that config map whether you want to use the proxy or not, and create a client based on the configuration you specified. For example, a gRPC client or an HTTP connect client, or just a normal HTTP client based on if it's the direct connectivity. So it's baked in. Every client has its own code creation based on that map. So this map is very important in deciding what connection you're going to use.
Okay.
So Adel, one question from me. So if we have other control plane components, third-party components, like you showed Prometheus, they also need to be able to import these special connection libraries, or?
We're not using any connection libraries. We're using, so to talk to the chute, we're using the proxy sub-resource, which is basically allows us to completely get rid of any third party or proxy or sidecars to that component, whether Prometheus or something else. In case of Prometheus, we're using the proxy sub-resource to port or to send traffic to either pods or services or nodes. So it's going through the API server.
Mm-hmm. Okay. So that means we just help me understand. So it's like HTTP proxy kind of setting. That
I can let's look again at it. So about how it does it. Sorry. So this is without the proxy. So here, because we have the tunnel, so we can use direct IPs. And here with the proxy, for example, and with the proxy, we're talking, as you see here, to sorry, one moment. We're talking to the API server here, as you see, and we just have a sub-resource called a proxy, and we just tell it what port to connect to, and what type of component we're connecting to. So in that case, I'm saying, hey, just use the proxy sub-resource. to talk to pods on this port, and I'm using a relabel from Prometheus to say or to disregard certain pods that I don't want to talk to. And as a result, here I have a list of endpoints, which are pods to talk to. Yeah,
got it. I missed that part. You were going too fast earlier.
Sorry.
But does this work for arbitrary tools, or are there tools which which might need I only talk to IP addresses or whatnot?
I mean, if there is a tool that says I only want to talk to IP addresses with special for special reason, then we would have. I mean, I don't see it happening, but we would have to implement or use again the proxy protocol. But we would have to implement or add a sidecar to that component.
Okay, got it.
And another thing, instead of UDS, you should probably use in this case the component should be separate, like the proxy which is running on the seed cluster should be a separate resource, and then you can use.
You can use the same component, but I mean, in terms of performance, I mean, you still have to. If you don't use UDS, you still have to use certificates again for every component, client certificates, which is also, I mean, an overhead. But this is again in implementation details. Whether you attach it as a sidecar via UDS, and then you require no certificates whatsoever, which is sometimes painful, or you can have a special one proxy server component that is shared with all the clients, third-party clients, and then talk to it via TLS. That's a choice, and it's only available if you are using HTTP. If you're using gRPC, you have to use GDS.
Thank you.
Thanks, Adel. Do we have any additional questions? So Andre apologized. Huh? Go ahead. Someone try to start talking?
Yeah, I heard someone start to talk in the background, but
okay.
Probably, yeah.
So Andre apologized, so he couldn't prepare the presentation for today. So we moved this topic to another future date. So if there are any other topics you want to discuss, we would have time now. Anyone? Seems not to be the case. Then thanks a lot, Adel, and see you in the next meeting.
Have a nice day.
Thank you, Adel.
Thank you very much. Great presentation.
Yep.
Thank you.
Yes, very good. Thank you.
Thank you.
Thank you. Have a nice weekend. Bye-bye.
Yeah,
Bye.
See you.